everyone. Welcome to Ri3D Redux. This is our day 3 recap. Very exciting. We got 2 robots that are pretty complete. They've all got issues that we're working through, but you know, and we got some autonomous stuff to do, and we got to test them more on the elements and that sort of thing. We've got some subsystems to show off. It's pretty cool. 2 very different robots, so that's pretty exciting.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Stryker is one of the world-leading medical technology companies and is driven to help make healthcare better. Stryker's commitment to innovation has made it a career destination for engineering professionals. Click the link in the description box below or go to careers.stryker.com to discover your next opportunity.
They both have the same drivetrain, the Swerve Drive Specialties MK4i. It's the L2 ratio going on. I'm going to turn it over to Steven, and he's going to cover that for both robots.
Hi, my name is Steven Carmain, and I'm the head coach of Team 2832, the Livonia Warriors. Yes, so when we started with a practice chassis that was 28 by 28 inches square, and then we made a second chassis based on what the field game demanded. So this one's actually 25 by 30 inches. Both robots are using the MK4i Swerve Drive Specialty Swerve Corners. They actually share the same code. They're using the Thrifty Bot Absolute Encoder on them. It took us a while to get them up and running, but now that they're up and running, we're able to move around the field. We can do all the control we want. You guys want to drive really quick? So Bot 1 is more functional right now. It's almost ready to go try game pieces. So we're going to spend some time with Bot 1 actually trying to see what type of autonomous sequences we can get done on a real practice field for tomorrow. So I think that's all we got.
All right. Do we have any questions on the drivetrain?
We've got one, well, related to both. So from Soka Juice, what are the dimensions of both robot frames together? Thinking if they were Alliance teammates, how much room would be left on the charging station for a third robot?
Yeah. So this one's 28 wide plus about 6.5 inches of bumpers. This one is 25 wide plus about 6.5 inches of bumpers. So sum those together, subtract, a bumper edge on each side, and so there's a little bit of bumper overhang, and it's 96 inches long. I can't do the math on me right away, but it's probably going to be somewhere in the neighborhood of you could get away with like another 25-inch robot, so another one like this if they were all butted up against each other, approximately. But I'm just kind of swagging it in my head. Next question, or any more questions, or go on? Oh.
All right, from a Flaming Fox, I believe yesterday there were 3 cameras on one robot. Why so many, and are there other options rather than extra cameras?
When do you guys want to cover that? All right.
So yeah, most teams do use one camera, and one camera is usually good enough to align yourself. So say on a robot like this, there's one camera down here, and using this, if you're trying to align to place a cube or a cone, that's good enough to, figure out if you need to move 6 inches to the left or 8 inches to the right. But what you can do with more cameras is get more accurate and more often readings of where you are on the field. So with April tags, what you can do is the moment a camera sees an April tag, you can know exactly where you are on the field and which way you're pointing. So even if your swerve odometry gets messed up or something, you don't have to worry, the camera's got your back. But it only works if your camera's looking at it. Now, if you have a camera, say, on each side of the robot, now it doesn't matter which way the robot's pointing. It's a lot more likely that it's looking at least one April tag.
All right, from Timmy and GA, how hard was the swerve code to implement and debug? Was this your first time with swerve?
So this is actually my team's second year with Swerve. We use a different supplier, but both code bases we actually use the standard WhippyLib code. There's an example project that talks about how to do Swerve. Just follow the steps, set up the kinematics to say where the corners are, and they'll do all the cool math for you. And then at the end of the day, it returns what angle the wheels need to be at and how fast they want the wheels to spin. The only holdup that you might have is to make sure you get all your units in the correct direction. WhippyLib really likes radians that are positive counterclockwise, and make sure your gyro is positive counterclockwise also.
Any more questions or next subsystem? All right, we're moving on to the next subsystem. So next we're going to talk about the arm and lift on this robot. I believe is this one, robot one. So I'm going to turn it over to Chris, and he's going to cover that.
Thanks, Ben. I'm Chris Herzog, 4292 Lockport Porter Bots and 4241 Joliet Cyborgs and Steel Tigers. We're going to talk about the manipulation mechanism here. It's a different approach than the other robot, so you're going to see two different ways of doing things. We have an arm, a fixed length arm. It pivots from down here. Now this is the elevator. The elevator moves, so this gives us the ability to change our geometry. We can change when we're reaching down, picking up a piece from the floor. Also, since we're fixed in reaching out, we can lower the arm to a horizontal position, but we can raise our arm. This lets us score on the higher scoring locations and also lets us pick up from the higher locations as well. We focus a lot on the floor. We focus on being able to pick up game pieces from the floor and cones that are primarily upright. So our mechanism here is designed to primarily grab, hold. We can manipulate the height and the angle so we can drop it onto higher shelves or drop the cones onto other pegs. So it's very, very straightforward. There's not a lot of complicated movement or joints going on here. We just take care to make sure that we've got a way to stow our mechanism when we're in the starting configuration to not be outside of our frame. So very straightforward. We're going to talk a little bit more about the vision, but we see in this robot has one camera mounted low, designed to sort of see directly into where we're working, and be glad to answer any questions about this. Back to you, Ben.
All right, from Jacob6838, how far does the arm reach and what levels?
You want to cover, or I can either way?
You can go ahead.
Okay. All right. So the arm reaches out. Let's go ahead and tape measure it. You want to drop the arm down, and we can say how far it reaches out to about where a cone would be from the bumper. We are
24 inches to the center of the cone.
about 24 inches here. So this is enough to get. Yeah. Yep, this is enough to get a cone on the level 2, or obviously you could get the box on level 2 and possibly boxes on level 3 with a little bit of spit. And it's able. The idea here is you'd be able to get them out of the feeder station as well, upright cones. So you could go in there and just shove your gripper into the feeder station and suck them down, and make pretty quick cycles that way.
All right, we got several questions here. About the arm, Timmy NGA. Arm speed can be faster with different gear ratio, or is this ratio optimum for the weight?
Yeah, I would say this arm is a little bit heavy out here. If I was doing this on a more production robot, I'd probably try to finagle in a gas shock or something of that nature into it, just because it's it's a little bit floppy, and especially this motor mount right here could be made a lot more rigid. But for a 3-day robot, from showing the principle of like where the geometry is going, you could do something like this, but you'd need to shore up the fact that it's kind of heavy out there, with maybe a little bit more rigidity back in the in the carriage of your system. Yeah.
both the elevator and the arm are running at about 3 volts of power, around 25%. So you could definitely change gear ratios and make it move faster. We were moving it a little slower while they were presenting because he was right next to it.
All right, and a couple of drive questions from Timmy and GA. Any issues or lessons learned on the Neos to prevent burning them up?
So we haven't had any issues burning up the Neos here on Robot in 3 days, but my team did have issues last year with our swerve corners. They had Neo 550s, and the biggest thing is while you're doing PID control to control the angle, once you have the angle where it is, you really need to stop the PID control. We were pulling, 0.1% request, and it was burning up our motors while we were just sitting here idle like this.
All right, and from Bobinator989.
Sorry, I want to add on to that.
Oh, yep.
Hi, I'm Kevin from Team 3260 Sharp out in Pittsburgh. And one of the things that we had issues with burning up our Neos on an off-season robot was that whenever they came from the factory, the current limit was set really high. You can go into the interface and actually lower the current limit, so you're going to be less likely to burn out your Neos.
All right, so question again, or did you figure out why the encoders on the swerve modules were not accurate?
We don't have a definitive answer. The closest that we figured out is basically when we mounted the magnets versus where the encoders sat on top. The magnet's a little off center or off scope. So the field as it generated around in a circle actually made a really nice S pattern all the way around. And so I think it was just a mounting issue. If we would have had more time, we could have 3D printed a different case to make sure that the magnet's directly over the sensor.
So on that note, just regardless of what supplier you use for your swerve drive encoders, you just want to make sure that, take the lesson from us that you want to make sure you install them correctly in there, because it's going to definitely improve the readings that you get from that, and then you don't need to, square your wheels every single time.
And because they are glued on, you can also come up with a corrections table instead of having to center them every time. So you could have a corrections table that this value equals this degree, and you'll just have a lookup table to be able to figure out what angle you're actually pointing at.
All right. From Elate05, would you be worried about the cubes bouncing out of the cube nodes?
Could someone remind me what their cube node is?
That's the scoring place for the cube.
Oh, the cube. Okay, gotcha. The little platform thing. Okay. Yeah, not super worried. The idea with that is you'd just be able to drabble them out. And actually, that's a good segue, because we're going to talk more about our gripper. We've got a great video about this on First Updates Now's YouTube channel, but we're going to talk about it here too and do some demos. So I'm going to turn over to Luke.
Hey, before we get a little bit further, let's start our first giveaway of the evening. Actually, Samantha is going to be giving away, go on camera and show them off. They're pretty awesome. So, or as well I am to say, they're pretty dope. So it's got some sticker packs that are robot-themed sticker packs in there, so we can get those in frame. So pretty cool. We got 2 sets of them. If you're interested in winning that, we'll draw when we get to the next robot. Type in Kevin in chat right now. Let's see Kevin spammed all over chat. Type that in. Don't forget, you got to be following in order to win. And we do give ourselves a little bit extra luck just because we rig it that way for them. So we'll draw in a little bit. Let's get back to more robots as well.
No, it does not. Kevin's sticker is in draft.
Alrighty, so my name is Luke, and I'm with Team 2481, and I was really helping out with the gripper design. Based off the iterations from the first night, you notice that this one's a lot smaller, and then the most recent video, we just did a video on this, kind of explains in depth of what the main point of the gripper is. But for now, what this gripper can do is it's run off surgical tubing on the inners, which make these fingers, it gives them the ability to kind of bend and form with the cube or the cone, whatever one's entering the robot. and then we use these 2 bag motors to help drive the compliant wheels and the star wheels. And in the back here, we have the time of flight time of flight sensor that can sense when you have a cube or a cone, and that will stop your intake from running, so you don't over drive on the backs. Overall, we haven't changed a whole lot since last time. The first iteration was just super big. The only downside to this is that it can only pick up cones that are in its upright state. So if a cone is, let's say, stacked on the ground like this, it wouldn't be able to pick it up. And this would be more beneficial for autonomous period when the cones are already up. And if you're picking up from your human player station. Other than that, you can find a cone that's upright, or you can go around and collect cubes.
One other thing that's worth pointing out, software controlled. So the speed of intake and the speed of the load and unload can be different. I had a question about whether you'd end up bouncing cubes out and the like. Well, one of the things that we like to do here is we tend to run a higher speed pulling in, because everything's more positive. It pulls it in, it gets it in nice and tight. You can choose your unload speed so that you're not launching these things out, that you're more sort of squeezing it out, and that may be an advantage. You could look at taking a different speed for cubes, different speed for cones, because they're going to manipulate a little differently. You're placing them a little better, a little differently. A cone probably can help with a little toss. A cube, you probably want to eject at a slower speed to kind of drop it on the shelf. So this is a place where you can do a lot of optimization if you're using a similar kind of design.
All right, question from Timmy and GA. How important is the time of flight sensor?
So the time of flight sensor, it's from playing with Fusion. It's really useful for being able to detect the distance of basically that anything is away. So in this particular case, when it sees a game object, it triggers and tells us that we can turn off our intake and we don't have to keep running the motors. We also use one in our elevator at the bottom here that tells us how tall our elevator, basically where our carriage is at each of the different spots. So like if we run the elevator all the way up, it's going to stop at the top. Let's run it up. Keep going. Yep, and then it can't go any further, and then run it down, and there's going to be a spot that it stops and can't go any further. So, they're very useful here. We're looking at putting one on this robot too, playing around with it. We've got one on the gripper. We'll see if we get in there. But in this particular case, this is 2 applications of the time of flight sensor that we've used from playing with Fusion.
All right, and a question I had missed earlier. How tippy is the robot when the elevator and the arm are up?
We'll experiment with that when we are over at our at the 2481 shop. We're looking at going over there soon because there'll be more carpet to run around and make movement.
So, guys, we got a lot to cover still tonight, so we want to make sure we do keep moving forward. Is there anything else on this robot we want to cover before we move over to the next one? So let's
that's it for this robot.
Let's draw for the giveaway before we get going. So once again, that was from Sapphire Thunder. Go check out Samantha Sapphire Thunder on where you look on Etsy now, right? So
No, it's my own site.
on her own site, you have to go check that out. So we're gonna draw for 2 winners for that. Keyword was Kevin, by the way. So if you got it in, very good. First person, Super MC Matrix. Congratulations, you're going home with that. 2 bags of sticker packs, once again from Samantha at Sapphire Thunder. And the next person is going to be Timmy in GA. I think that's a well-earned giveaway for how many questions Timmy's been asking. So congratulations. Make sure you send First Updates Now a message, and we'll get to that after the show as well. We need all your shipping information. And in a little bit, we're going to be doing a giveaway from AndyMark for a official game piece, the cube and cone that the AndyMark crew is going to sign and send out to you. So we'll let that compressor finish up, and then we're going to go into the second robot here, Ben.
Yeah. Does it come through on my mic?
I don't know. We'll find out.
All right. I guess we'll find out. Yeah, clearly you could see we've still got gremlins here because this robot decided to, fire its cylinders there. Lost comms for a second, yes, and then because we're using single-acting solenoids, you saw that happened. So highly suggest if you use a mechanism like this, use a double-acting solenoid on your own robot. But Okay, we were saying double acting without spring return over here, but I mean just basically a double acting solenoid on its own. You're going to be good on that one. Okay, so with this robot, we're going to start going through subsystems. We're going to do intake first. I'm going to turn it over to Matt.
Okay, so this intake is very similar to the prototype that we showed on the furniture dolly, and it's getting integrated into this robot. It's maybe a little bit wide for the frame perimeter, but that's all things that are kind of constraints for a robot in 3 days. So while we go ahead. All right, so right now, this does kick up the game pieces up, but we need to work on controlling where those game pieces are going into the robot to get the handoff to work nicely to the arm. So right now we are like just launching the game pieces up into the robot. Well, maybe not launching, but they're going a little bit too far and not in a controlled manner because we need to corral an area for the arm to come down and grab them. It's a little bit of a more complicated solution to solve because doing a handoff with two moving pieces, you're picking up a piece that's moving on the field, and then you're trying to grab a piece that's moving into your robot. So we're trying to control how that piece moves into your robot. You can see we've added this polycarb to the top to try and deflect the pieces down a little bit. And what's coming up next will be maybe another roller that's going to go right across here. Because as the game pieces come in, is it worth actuating the intake right now? Yeah, maybe not. Yep. So right now, basically the game pieces are shooting too far up into the robot, and we can't control the location of the game piece into the robot well enough to be able to grab it with the arm. We could maybe jostle the robot to get the game piece where we want it, but really we're trying to fine-tune this handoff, and that's something that you may want to consider when you're prototyping these ideas or thinking about going this way. Is like, this is a much more complicated problem to try and solve, and again, we've only had this prototype initially and integrated in the robot for like 3 hours. So we're doing our best, and we're constantly changing little things here and there to make the multiple subsystems interact with each other. So also on this intake, we are using a lot of 80/20, which is pretty heavy. And it's very much for a prototype. If we were going to productionize this, we'd maybe CNC out side plates out of polycarb that would have bearing holes right where we would want them. We would maybe consider a little bit more robust solution than the infinity belt to reverse the rotation of the rollers. But just so that we know, this lower roller spins this way to keep the cones up, and the top roller spins that way. So it kind of comes up to the cone, sucks it, throws it up into the robot, and now we need to work on handling that game piece as it comes in to bounce it down and get it into our like little box. Initially we had just a cardboard box to lay this out, and you can see we've moved on to polycarb and 2x4s. So we are getting more and more sophisticated. Thinking we're having some little bugs with code. Do we want to start talking about the arm, or is there any questions about the intake now? Okay. Does anyone want to talk about the arm?
Hi, my name is Tim. I'm a lead technical mentor for 4467 and one of the mentors for 3504 out of Pittsburgh as well. So what we have here is we have my coffee down. Coffee is important on 3-day builds. So what we have is we have a ThriftyBot telescoping tube system that a lot of teams used last year for their lift for traversal climbs, everything else. So it's got a Delrin block in it and just 2-inch tube here, 1.5 here. We've kind of talked a little bit about it a couple times. We've sandwiched on using some clamping gearbox or bearing blocks, a system on this that allows us to have a sprocket, and then using hubs to lock this sprocket to the rotating. We now have a encoder on the side over here using a through-bore encoder from Rev. So that gives us positioning of the arm as we move that. We have it driven just through chain down to a max planetary right here. So now we can move that. And one of the things to be aware of is that this arm is only spring tension going out for extension. It's not a system that is powered out. And we've had a little bit of problems with the weight of the intake or the gripper here, allowing for the arm to come back down while we've been moving it. And if your manipulator down here was a little bit heavier, you might have that. There's a couple ways to work around that. The first would be to get bigger springs, constant force springs for in that. Different companies, McMaster sells a couple different versions that would package nicely in there. Another way would be to think about pivoting or taking and powering that system out. You could do that with some complex rigging. You could do that with chain. Argos has used a couple different solutions in the past. One or two of them are featured on videos that go over their robot that they made in 2022 for Worlds that are on Fun. So pretty cool system that they have with chain and just holes in tube there. So as this moves up, we then can extend out and score over here. We have a little bit of a height issue down in the basement, so we've been doing it kind of slow. You can see, again, there's packaging problems. None of these robots are perfect. We've built them very quickly. I would encourage, if you have the ability, to also build quick robots because you learn a lot from these. So it binds up, again, because of the not powered out solution. So it can't go out when you have this weight. You could compensate by controls and tipping that down, but that's a little bit difficult. So just something to be aware of, as a lot of you are familiar with this. You could build this and practice, and then while you've built this quickly, you could then design another iteration of this arm that might be your competition arm. So that would allow your drivers to practice a lot. Any questions on the tube?
Yes, from IGN LR8. How often do cones get stuck?
A lot more than we want them to be. This is really handoffs between mechanisms in robots are very hard. The benefit of a solution like this is there's a quick intake. We found through a lot of our testing that dealing with cones in a lot of different orientations slowed the intake process down. What this solution has is the ability to intake this in 1 second or so, but we don't have the ability. So now, in that short amount of time, we have that in our robot. So it's not perfect, right? So a little bit of coaching. Again, system's not perfect. The benefit of something like this is it allows you to get it into your frame and then be driving while you do other additional manipulation tasks. So it maximizes the cycle time that you have. Is it a complete, here's the problem that's solved, duplicate this? No, it's an inspiration and possibly a path forward to let you decide what you want to take your team and allocate some additional prototyping resources for. So, Any additional questions, Samantha?
A number of them. All right, from Timmy and GA, what are the paddles made from?
The paddles are made from plywood, and then the gripper material right here is just a foam drawer liner that you can get at Walmart at 2 a.m. Or you can get it from Ben's supply drawer upstairs in his kitchen. So Ben has given some sacrifices to the Ri3D project with his house.
Yep. All right.
Sorry, I just want to go over one of the reasons why it didn't actually correct, like, come over here correctly. So one of the things that we ran into was we needed to shrink down this gripper design to be able to actually fit inside the pistons for the intake portion. So right now the pistons are over compressing the cone, and if it was just a little bit wider on this cutout here, it would have been able to go all the way through and then been in the correct orientation.
So you could CNC or do some other cutting and stuff like that to do another iteration on that build. Additional questions?
We're going to start our next giveaway as we keep going on here. So we're giving away an official game cube and cone from AndyMark, and the AndyMark team is going to sign it as well too and send it out to you. So if you're interested in winning, type charged up with the exclamation point at the end in order to enter. So make sure you get that exclamation point. Don't forget, you do have to be following our channel. We do give our subscribers a little extra luck. If you didn't see, by the way, we got some cool new emotes as well too. Samantha created the happy cube and the angry cone emotes that our subs get as well. So if you're a sub, we really do appreciate that. But type that in. We'll draw for that after we're done talking about the robot. I know we got a couple more questions.
All right, from Papano1X, how is the motor and gearbox mounted on the arm?
The motor and gearbox are mounted on the arm right here. This one, we'll talk about that. This is just direct mounted to the tubing, which you can do with the Max Planetary setup. So we have that set up right there. No bearing block or anything. If you were paying attention to live stream, I streamed that for like 2 hours while I was like working on the assembly of this. So it's pretty simple. You just center punch a hole and do a scribe and drill some clearance holes for 1032, and then it mounts on. For the rotation rate down here, again, we have the hub and the bearing block that are mounted together using an AndyMark bearing block, and then some ThriftyBot hex hubs that lock the rotation of all of this together. And then that goes down to a Max Planetary that we have mounted on some gussets and one of the Max Planetary or the ThriftyBot Ultra plates, I think it is. So.
Yeah, to get specific on that plate, it's a ThriftyBot product that's part of their elevator kit. So it essentially has holes every half inch, which is great because it's useful for a lot of other things too. So we borrowed it out of an elevator kit to put on there.
All right, question from Elate05. How many pounds of pressure are you using in the pneumatics?
We're currently using 60 for the working pressure.
All right, and another question from Timmy. The intake looks stout. Any concerns on bending those pneumatic cylinder rods with an impact when it is down?
Yeah, I mean, I would say that you should iterate and really consider packaging on your intake here to make sure that you are within frame perimeter and that you create a durable intake on this. In general, it's wise to create systems that have the pistons retracted when the intake is out. However, that means that it's pretty complicated to design that. It's a lot easier in this situation to hold up some 80-20, mount it, and then hold it with some fingers and move it and say, yep, this is where we're mounting. So in 3 days, that's what we did. Again, one of the benefits of doing a fast prototype like this is that you could take this to a practice field or just open carpet and start driving it around, and you can discover those problems during testing. You can discover how stout that really is during testing because I guarantee your driver's going to probably drive into a wall a couple times as they learn to get used to it, and especially because of where the cones are against the human feeder stations. Any other questions?
We got a couple more, and then we'll wrap up.
All right. From Nukem K, does this bot fit into starting config?
It is. Does this all fit into starting config? It's very close.
Yeah, there's a couple things that aren't. Can you bring the arm down? Yeah. To start with, on the intake, there's a few shafts that we left long. You could lop them off and you'd be in starting config, so it's not too bad. This tube, we only had one, so we didn't want to cut it down. So we went ahead and left it long, but it wouldn't be too hard to package it, this motor, into the rest of it. So we're not super worried on the starting config, but we didn't necessarily prioritize it for working on mechanisms and getting them done.
All right, from Timmy, any experience or guidance in dialing down working air pressure from 60 psi, or does that add another variable that can be unreliable?
You can have a downstream regulator and have some of your solenoids be on a lower working pressure, and that's fine. Sometimes the mechanisms requires it.
Yeah. So AndyMark specifically has a really awesome, really small, compact pressure regulator now. So in the past, pressure regulators used to be large things, but this can just be inline now, anywhere that you want to put your those are needle valves, so that just restricts the flow rate. That doesn't restrict the working pressure. So that is just a flow rate limiter. The needle valves was what he was talking about. This specifically is able to give you a secondary working pressure. So what you can do sometimes even is having the working pressure extending or retracting being higher than the other, and then that allows you to have something that softly closes, and then you also can save air if it's a large bore cylinder.
All right, from Light 032 unit, would Mechanim Drive still be viable in this year's game? The main concern would be a slipping issue when driving onto the charging station.
Yeah, so there's a couple things you need to worry about if you use Mechanim Drive. Number one, you lose a little bit of your pushing force if you do that, and you're a little more susceptible to defense personally as you move around the field. So that's something that you just have to consider as you do that. Another thing with Mechanim Drive that you also have to worry about with there is the slippage on the platform, like was mentioned with that. And so it's both your ability to play defense and also your ability to execute defense at the same time. So those are just considerations that you have to work through there. You can consider it, but it's really up to you if you want to go that route. There's a lot of information out there about that.
All right, from IGN LR8, do you think that the intake plus an active funnel would work to get the intake into a consistent direction?
Potentially, it could work. You'll have to prototype it and try it.
All right, so I know we might have missed a couple questions went through, but we do have to wrap up as we go through here because tomorrow, Ben, we're actually going to be at a new facility, right?
Yeah, the current plan is to go over to 2041 shop, and we can test out with some of the field elements over there. We actually already moved all the field elements. So as soon as I get the all clear that the students have gone home, then we'll go head over in that direction.
Which means we do have to pack up all this stuff, including all of our equipment here at Fun 2. So we will be ending the stream earlier tonight for the reveal tomorrow. Now, the reveal is going to be tomorrow. It will be around about, 1 p.m. Eastern, I think is going to be the timing for that.
That's the current plan.
So we know some of you are going to be in school and stuff like that. Don't fret. We'll put this on YouTube, but we like to end within the 72-hour period. So that's the reason behind that. So make sure you check out, of course, all the videos coming up on youtube.com/firstupdates. Now, hey, let's go ahead and draw for that giveaway from AndyMark. Once again, that was for an official GameCube and cone that's going to be signed by the AndyMark team and staff.
So cool.
Yeah, right?
Yeah. There's so many awesome people at AndyMark. So
there's at least 3 and a Canadian. So
we got one of them right here.
Charged up. Yeah, we do have an AndyMark employee here. Charged up is the keyword for that. And it's going to be C Harvey 829. Congratulations, subscriber. Lots of rigged emotes in chat. Clearly we rigged it for C Harvey 829 to win. And by the way, huge thank you to all the follows and subscriptions and bits we've gotten as well too as those watching on YouTube. We had over the last couple days well over 100,000 views on this Ri3D content so far, and we are so grateful for all of you tuning in and checking out all this as well too. So Ben, before we wrap up here today, any last things to talk about before we end the show?
None on my end. I think there's a lot of other cool stuff that we got going on these robot, but we got to wrap up. There's a lot, especially on the software side. But we'll keep testing on those things. Hopefully, get a little bit more iterations in place. That way, we can show some of that cool stuff in the reveal tomorrow.
All right, so let the R3D thing get back to work. Like I said, the stream is going to end probably in a little bit once we start to wrap up stuff as they start packing up. We'll leave the cameras on for a little bit longer, but thank you so much, everybody, for tuning in once again. If you can tune in tomorrow at 1 p.m. Eastern to see the reveal, we'll be on do they have a full field there?
Then we won't have a full field. About half of the field is covered in stuff because we just got the building. But they have a lot more carpet and a high ceiling, so there'll be more space to run around.
Perfect. So make sure you tune in for that. We'll be on about 9:30 or 10:30 a.m. Eastern as well. So you'll see us for a couple hours tomorrow and check out our videos on YouTube. So thanks a lot, everybody. Appreciate it. We're going to let people get back to work and as we start to clean up and move stuff over. So thank you, everybody. You can still ask more questions in chat. If you didn't get to them, we'll still get to those after the show. Thanks, everybody. Let's get everybody back to work. And chat, give everybody here at R3D a big round of applause in chat. We appreciate you. Thank you. This video on First Updates Now is made possible by viewers like you and also the following sponsors. Stryker is one of the world-leading medical technology companies and is driven to help make healthcare better. Stryker's commitment to innovation has made it a career destination for engineering professionals. Click the link in the description box below or go to careers.stryker.com to discover your next opportunity. At Kettering University, over 30% of the student population was in high school robotics. These same students have received a portion of over $7 million in scholarships. Scholarship applications for FIRST students are now available. Get more information at kettering.edu/first. Thank you to all of our suppliers and sponsors for the Robot in 3 Days Redux and Kettering Bulldogs programs.